All right, we're going to do some practice on the binomial and geometric distributions. The first thing I want to do is clarify what the difference is between your binomial and your geometric. Now, I am on page 88 in your packet. So page 88 is what we'll do in your packet. And by the way, your homework or your assignment will end up, actually, and I want you to work on this in class, is going to be the pages 89 and 90. 91 also has some practice if you needed more. But as far as the assignment goes, pages 89 and 90. All right, first of all, the thing that is the difference between binomial and geometric, because they do both have success or failure probabilities. Success of this, failure is the other part. And they also have all the independent events. So the probability is not changing from a trial to the next trial. Here's what's different. Binomial is out of a set number of trials. So it'll say, out of 50 trials, what's the probability you have at least 10 successes? So it's out of a set number of trials. But geometric is not a set number. Geometric is a situation where you have trials until you get a success. So you don't know how many trials you're going to be doing. It's just until you get a particular success. Or they may say, what's the probability that that particular success is occurring in that fifth spot? So you know the order. Now, one other thing I wanted to talk to you about as far as these goes is the expected value. So what would we expect? So if, say, you had 50 trials, the way that this would read for a binomial problem, you would say, out of 50 trials, how many heads on a coin flip do you expect to get? Well, expected is the same as that mean. And, of course, we know from yesterday that that is your n times p. So out of 50, and half of those are going to be heads, I would expect there to be 25 heads on average. And so it could be a decimal value. That formula is on the formula chart, as we saw yesterday. The expected for geometric is not on the formula chart. So the expected for geometric that you have to have memorized is 1 out of p. How many do you expect to go? How many coin tosses do you expect to have until you get a heads on the coin toss? That's 1 out of p. All right, so let's go through and practice these problems. And we'll talk about where these things are on your calculator, how to do these on calculator as well. All right, first question. And again, we're on page 88. A basketball player has made 80% of his foul shots during the season. Assuming that these shots are independent, so making one is not affecting the probability of the next one, each time he goes up there, it's an 80% chance of having a success. All right. He misses for the first time on that fifth attempt. He misses for the first time on that fifth attempt. So the way that would look is he makes this, makes this, makes this, makes this, and then he misses it. So what I've got going on is essentially, let's see, making it, so 0.4 or 0.8 to the fourth power, because these would all be 0.8s. And then that last one is the missing, which would be the 0.2. Okay, so there's how you would compute that. The answer you get when you compute that problem is 0.08192. So you could check yourself on that. But I want to give you a calculator shortcut. A calculator shortcut could be, it's a geometric problem because we're going until, but I want to put that success in a particular spot. So if you wanted to do a calculator shortcut and you don't have to, You could do geometric PDF, because I am putting the success in a particular place. So you do geometric PDF, and I'm going to put 0.2 in the 5th spot. So I believe in your calculator, it's under second vars. It's in the same place where the normal model stuff is, so norm CDF, inverse norm. It's in that menu. There's the binomial PDF, and then at the very bottom is the geometric. All right, next. Makes the first basket on his 4th shot. So that's again defining. Let's see. Misses, and then makes it. So that is your, let's see, what is this? Misses 0.2. Okay, and then your 0.8. And then if we were to do this in the calculator, let's see how that would be. Geometric PDF, I want to put this 0.8 in a particular place. I want to put it in the 4th spot. So geometric PDF. The answer for those, if you do that correctly, comes out to be 0.0064. So there's how you get that answer there. All right, moving on. This next one's a little bit more involved because it says he makes his first basket on one of the first 3 shots. So the success could be in the first place, or, that's addition, the success could be the first time you have a success is in the 2nd spot. So that means you missed it and then you made it. Or the first time you have a success could be in the 3rd spot. So that means you missed it, you made it. Okay. Now, let's see, that would look like all of this fancy numbers. You'd have these 3 products added together. And when you do that, you get 0.992 as your answer. But let's have a little discussion about a shortcut way to do this. You are accumulating a success in the 1st or the 2nd or the 3rd spot. So this is a situation where it is not a geometric PDF. You have a geometric CDF because you are accumulating a success, and that 0.8 is my success, in up to and including the 3rd spot. So in the 1st or the 2nd or the 3rd. And that's how you would get that answer there. All right, let's practice one more. Let's do number 2. It's another geometric one. Let's see if you can't follow along here. Okay, number 2. Suppose the computer chip manufacturer rejects 2% of the chips. So good is 0.98, bad is 0.02. What's the probability that the 5th chip you test is the first one that you come to that is bad? So lay that out. That's saying that, let's see, these first 4 are good. And that 5th one is the first one that is bad. So you've got the 0.98 to the 4th power with that 0.02 being in the 5th spot. If you were to shortcut this in your calculator, let's see, what would we be doing here? Geometric PDF or geometric CDF? So we just have this one situation, a particular placement of that bad chip. So I want to put that 0.02 in the 5th spot. So that's how that would come out. The answer for this problem ends up being 0.018. All right, the next one, I have 2 options of how to do Part B. What's the probability that you find a bad one within the first 10 that you examine? So one way to think of this is, you can say, this is a bad one, and it's within amongst those first 10. So you could say it's in the first spot, or it's in the second spot, or it's in the third spot. So you are finding a bad one in the first spot, or the second spot, or the third spot, and so on. Which means you are accumulating all of those specific placements of the bad one. You find a bad one within the first 10 that you examine. So you could do this, a bad one, 0.02, amongst the first 10. Now, that was kind of like, this was a second way I had thought about doing it. I believe if you calculate that, and I really do need somebody to check on that one. I don't have my calculator here at home when I'm doing this recording, but I need that one to check, because my original way of doing this problem, if you find a bad one, I was thinking that means you find at least one bad one. So if you are finding a bad one, that's the same thing as saying at least one. And what do we do for at least one? We have the probability of at least one. It's 1 minus the probability that none of the 10 are bad. And in order for none of the 10 to be bad, that means that they are all good. So that's 0.98 to the 10th power. So I believe that this is another way, and so there are two ways to think of that problem. Either accumulating it in the particular spot, or 1 minus probability of none. And whichever one comes out to be that 0.18, that's the correct way, which I think both of them are. All right, last geometric one here. What is the expected value? How many are you going to have to check until you get a good one? Well, if you look up here, see, how many do you expect to check until you find a good one? That's 1 over p. So the expected count will be 1 over p, which is going to be 1 over, let's see, we want the good one, 0.98. And so that comes out to be 1.02 as your answer. All right, so those are the geometrics I wanted to check for you. Now, let's skip number 3, although we'll have to look at some information on it to do number 4, and then we're not going to do problem 5. So here we go. Let's do number 4, which we'll go back up and read some information. So number 4 says, a group of 5 women become pregnant while undergoing fertility treatments with the drug Clomid. This was discussed in problem 3. So let's go up there and review. Problem 3 says that the probability of having twins is usually 1 in 90, but if you have Clomid, if you take the fertility drug Clomid, the probability of having twins is 1 in 10. So the probability of twins equals 1/10. Okay? All right, so there's our probability of success. So first, let's discuss this. Because this is out of 5 women, that's a set group, a set N. So we are going to be looking at a set number of 5 and then deciding what's the probability that there are no successes out of that 5, exactly 1 success out of that 5, or at least 3 successes out of that 5. So this is a binomial problem because we have out of a set number of successes. Whereas these problems up here, problems 1 and 2, were both geometric because for those two, we were going until we had a success. All right, so back down to this number 4. None will have twins. So that means I need all 5 of them to not be having twins. That's 0.9, 0.9, 0.9, 0.9, 0.9. So 0.9 to the 5th power is probably the simplest way to write that one out. And that answer is 0.59. So if you do that one right, it's 0.59. Okay, how about B? Probability that exactly 1. Here is that binomial formula, which you know you love, that we're going to have to write out. The probability that x is exactly 1. And so here's how that goes. So what we have is, let's do our combinations. 5, choose 1, success. Okay, now let's do the successes. That probability is 0.1 and I want 1 of those. Okay, now let's do the failures. The failure rate is 0.9 and if I have 1 success, how many failures are there? 4. So that's the work that you would show. And the way you would do this in your calculator is, again, you go to second bars where the norm CDF menu is, and binomial, PDF, and CDF are there. Because this isn't exactly binomial PDF, exactly this, exactly that, PDF is where it's at. So we would do binomial PDF of 5.1, and I want exactly 1 success. So if you do that, work correctly, you get 0.33 as the answer on this one. Okay, so 0.33 for part B. All right, let's do this last one, and I'm glad I've got some extra room to do my work for this last one here. We want at least 3 to have twins. So that's the probability that x is greater than or equal to 3. So if we think about this, 4, 5, 6, I want at least 3 of these women. Okay, so the way I can show my work is I show the first one in the sequence up to the last one in the sequence. So I would go 5, choose 3, which means the successes of 0.1, there are 3 of them. Failure 0.9, there would be 2 of them. Because I don't know if you've noticed this, but this 2 plus that 3 is a total of 5. Okay, so those 2 plus 3, those successes and failures will always total to that 5. All right, plus ... and then we'll do the last one in the sequence, which is 5, choose 5 successes. 0.1 to the 5th and 0.9 to the 0. So, the way you would love to calculate this is just binomial CDFing, cumulating from 3 up to 6. But our calculator does not calculate an accumulation from a midpoint up. The way you have to do this is take off the part you do not want. So we will have to go in the calculator 1 minus the accumulation of the bottom part I want to take off. So that's binomial CDF of 5.1, and I'm going to take off up to and including 2. So when I take off that up to and including 2, so that's the way that would compute in your calculator. the answer you get from that is 0.00856. All right, so in summary, those are the ways for you to do a few different kinds of binomial and geometric problems. Now, page 89, your homework, you're going to have page 89 and 90, which actually you're going to do classwork. But I am, if you would, go to page 90, and I'm going to look at this first problem with you and do it with you. And one last problem to do. All right, so here's a problem. We have 80% of graduates from Northeast High who applied to Penn State are admitted. So the probability of getting admitted is 0.8. Well, last year there were 6 graduates who applied to Penn State. So what's the probability of that? Exactly 4 were admitted and more than 4 were admitted. So I want you to think right now of how to write out those formulas. So I'm going to just let you try to think about how to do that. So write those down now. All right, so let's check these. Okay, so the first one, exactly 4 were admitted. So that's the way you would write that formula to have exactly 4 successes. Now, as far as calculations go, I would do binomial PDF of 6.8 exactly 4. And that would give you the number 0.24576. Okay? But let's take a look at the part B where it says more than 4. I actually had made a mistake at first and I put greater than or equal to, but look here, it is purely greater than 4. That means it's 5 successes plus 6 successes. Now, while there are actually 2 ways you can compute this, you could, here's choice number 1, binomial PDF of 5 successes plus binomial PDF, particularly 5 and particularly 6. 6.86. So you can do that, and that will get you the answer 0.65536, I think. Okay, so see, you could just add the 2 PDF of 5 successes plus PDF of 6 successes. Now, there is, if you were wondering, there is an alternative of how to do that problem, because if you have this situation and you want this 5 and 6, then, you know, the other way you could do this is by taking off this bottom 4. So an alternative way to compute this could be 1 minus the accumulation of those bottom 4 up to and including 4. You're taking off the bottom 4. And that would give you that same answer, 0.65536. All right, so 2 different ways to think about that. And the last 2 things are just simple formula. Right here, you got the mean, and we already had filled those out from yesterday, or I had talked to you how to do that. The answer for that, if you did it correctly, is 4.8. And then here, the standard deviation formula that we talked about yesterday. And if you fill those numbers in correctly, you get the answers 0.97 repeating, I believe. So, in summary, your assignment is to do pages 89 and 90, and I'm going to put the answers on the board for all those problems so you can check those. And so you should have about 20 minutes of class left to work on these 2 pages, and what's not finished in class is homework.